History of Mathematics. So for today, we are going to tackle women in modern mathematics. Among the more insignificant developments of the post-World War II period was the increasing role women played in the mathematics community, where earlier in the century they tended to spend their professional lives teaching at women's college or undergraduate colleges. Many now were trained to pursue careers in both teaching and research, but there were often barriers to be overcome as experienced by the following mathematician women. First is Julia Bauman Robinson. Julia Bowen Robinson in 1918 to 1985. She has the doctoral degree from the University of California, an American logician. In 2 decades, pioneering work leading to the solution of the 10 problem on Hilbert's famous list of 23 problems. This problem lies in the border of number theory and logic. As for computational algorithm that will determine whether a given polynomial equation with coefficient will have a solution in the integers. Robinson's results on the behavior of solutions of certain Diophantine equations. This also enabled a 22-year-old Russian mathematician Yuri Matijasevic to answer the 10 problems negatively in 1970. Mary L. Cartwright in 1900s to 1998. She is also an equally accomplished mid-century of Robinson. She is an England mathematician who earned her PhD from Oxford University in 1930, where her thesis advisors were G. H. Hardy and E. C. Titchmarsh. She accepted a 3-year research fellowship at Girton College, Cambridge, marking a lifelong association with the college. In 1934, she joined Girton's faculty as a lecturer and assumed the duties of Director of Mathematical Studies 2 years thereafter. In later 1949, Cartwright answered the call to become mistress of Girton, remaining the administrative position until her retirement in 1968. She published over 90 papers, most important of which involved joint work with John Littlewood. In 1938, thesis collaboration started before Britain entered World War II and lasted some 10 years. Governments were recognized with 2 of England's prestigious awards: the Sylvester Medal of the Royal Society in 1964 and the Morgan Medal of the London Mathematical Society in 1968. Mathematics in 20th century. A great incursion of new ideas, the branches of mathematical investigation were enormously widened, and its method profoundly deepened. So perhaps the most far-reaching development has been the effect of the computer revolution, in which can be regarded as a continuation of the scientific industrial revolution on the discipline. In the Babbage's dream of a fully automatic calculating device was the Automatic Sequence Controlled Calculator, or the ASCC, later known as the Mark I. First general-purpose electromechanical computer was completed in 1944. Mark I is a joint enterprise between the Harvard University and the International Business Machine Corporation. The Mark I weighed 5 tons, contained 500 miles wiring, and accepted operations instructions pre-punched into a roll of paper tape. The Mark I Multiplications operation was done by the addition of a partial products, just it would have been done by assembling a set of Napier's bones. So the machine kept running 24 hours a day and can handle calculations that would have taken 6 months. So now let's proceed to ENIAC, the first computer to use vacuum tubes rather than electrical relays and mechanical parts was the Electronic Numerical Integrator and Calculator, or the ENIAC. Appearing in 1946, it was designed and constructed by the Pennsylvania to produce ballistic ring tables for the U.S. Army. This ENIAC, or the ENIAC, weighed about 30 tons and occupied by 30 by 50 feet of floor space. The machine carried out calculations of 1,000 times faster than its nearest rival, the Mark I. For the ENIAC calculator, it has 18,000 vacuum tubes, wherein it is a serious drawback requiring too much power and producing too much heat. Universal Automatic Computer, or the UNIVAC, was the first general-purpose electronic digital computer designed for business applications produced in the United States. Grace Murray Hopper in 1906 to 1992 is one of the systems engineers contributing to the development of the UNIVAC. Flowmatic, the first English language data processing compiler in 1960 of the business-oriented language COBOL. Grace Murray Hopper received honorary degrees from their 40 colleges and universities. A few recent advances in 20th century. First is Paul Erdos in 1913 to 1996, one of the towering figures in 20th century mathematics. He published over 1,500 mathematical articles with aid of some 500 co-authors. He was been elected to membership in 8 scientific academies, received an honorary degrees from 15 universities. He was born in Budapest, Hungary. 1930, he entered Peter Pagman III University and graduated 4 years later with doctorate in mathematics. His thesis concerned about prime numbers in arithmetic progressions. He was being awarded a research position at Manchester University in England, a position that did not require him to teach. In 1938 to 1939, he declined to be a fellowship at Princeton Institute for Advanced Study as he accepted the position in England. In 1950, he was able to secure a permanent post at Notre Dame University. In 1975, he joined with John Selfridge in confirming the 150-year-old conjecture that the product of two or more consecutive integers is never a square or other integral power, explicitly that the equation the quantity of n plus 1 times the quantity of n plus 2 and so on, or the quantity of n plus k is equals to x to the power of r. has no solution for integers. K, R is greater than or equal to 2 and N is greater than or equal to 0. Next, Nicolas Bourbaki. This name was adopted by a group of 10 young French mathematicians. They named after Charles Bourbaki, a French general during the France-Prussian War. In December 1934, they discussing at Paris Cafe to write a new textbook, A Calculus for French Students, to replace Edouard Goursat's, but sadly, they outdated but widely used traited analysis. The founders of Nicolas Bourbaki was Henri Cartan, Claude Chevalier, Jean Coulomb, Jean Delsarte, Jean Deoudon, Charles Kerman, Zolem, Mandelbrot, René de Poussel, and André Well. Bourbaki work informed the new math a trend in elementary math education during the 1960s, declined due to a frequent publication of new volumes of the elements. Most collective recent publication in 2016, Treating Algebraic Topology. In 1939, the first book of elements, entitled Set Theory, consisted of 4 subsections, along with historical notes and challenging exercises for readers. In 1959, all 6 books had been completed. Order of publication was Set Theory 1, Algebraic 2, Topology 3, Functions of a Real Variable 4, Topological Vector Spaces 5, and Integration 6. After publishing the first 6 books, the members of Bourbaki increased to 15 or 20 members. Computer has been an invaluable research tool in furnishing counter examples to outstanding conjectures or in verifying conjectures up to specific numerical bounds. Example, Goldbach's conjectures has been confirmed for the first 2 times to the power 10 to the power 14 even integers, a factor which has roughly 7,000 decimal digits, has been found for the immense number of 2 to the power of 2, 3, 4, 7, 1, or 23,471 plus 1. The initial 10 billion zeros of the zeta functions have been calculated. For pi, expansion carried out to just more than 260 billion decimal places. Let's proceed to four-color conjecture. This was one of the most popular and challenging problems in mathematics, where states that no more than 4 colors are required to color the regions of any map, so that no 2 adjacent regions have the same color. In 1936, Apple and Haken found reducibility cases, each of which involved a computer search of up to 500,000 logical options to confirm its reducibility. 1611, a New Year's gift on the 6-cornered snowflakes. Johannes Kepler posed a problem in solid geometry that has remained open for nearly 400 years. So this was some recent advances. So pi divided by the square root of 18 is equals to 0.7405, the sphere occupying of the total volume of the box. In 1998, Thomas Hales of the University of Michigan provided a rigorous solution to the vexing geometric question. In 10 years spending developing a computer-assisted proof which totaled more than 200 pages, 150 variables reduces the problem. Squaring the circles in 1925, a memorable accomplishment that involved a modern version of the ancient Greek problem. Next is Alfred Tarski, a mathematical logician, asked whether there is a way to cut up a circular region into a finite number of pieces which can be reassembled to form a square with the same area. Extremely complicated, almost unimaginable in so that was the sum of people who stand out during the recent advances. So 20th century was a golden age for mathematics. Entirely new lines of investigation sprang up in almost bewildering profusion, touching upon such topics as distribution, chaos, categories, fractals, wavelengths, Markov chains, Penrose tiles, superstring, and so on. Each generation adds another chapter to an ending story of mathematics.